Thanks, Tim. Hi, everyone. My name is Amu. I am the Head of Client Services at Caitlyn, and this is a short presentation of a proof of concept we did with BSI to showcase Caitlyn's GraphRAG capabilities. Okay, so BSI is an agricultural science research organisation with a massive body of specialised research. Caitlyn was deployed inside BSI's own AWS infrastructure. Their data stayed in their environment under their control. No external data was entering either, which for an organisation sitting on commercially sensitive research is non-negotiable. Access ran off their existing Microsoft Entra ID managed by their own IT team. And that sensitivity led to a development called gated content. So when scientists ask Caitlyn a question, Caitlyn answers using only the materials that the person is actually allowed to see. But Caitlyn also does a wider search across the whole knowledge base for relevant information, including materials that the user does not have access to. While not showing any of the content to the user, Caitlyn lists the resources underneath the response. The user may be able to gain access to it by contacting the BSI admin team. Now, this tells the scientist research has been done on this, but you can't yet see it. Without it, they may assume nothing exists and go to repeat work that's already been done. And this isn't just a BSI problem. We hear it again and again from research organizations. Duplication of research is a real problem. The response is laid out like this: the response at the top and the sources following, and at the bottom are the other resources, which are relevant to the user's query, but they don't have access to these materials. You'll notice that the citations at BSI's version actually look slightly different. For researchers and scientists, the author and the year tell you an enormous amount at glance, how current the work is and who's worked on it. So for BSI, they opted for the author date citation method inside Caitlyn. Now for the part that really sets BSI's proof of concept apart, they used Caitlyn's GraphRAG capabilities. During the proof of concept, the Caitlyn team worked closely with the team at Neo4j, who are industry leaders for graph knowledge bases. What sets vector-only RAG and GraphRAG apart is how the ingested material is structured and then retrieved by an AI agent. So most AI search systems today use a vector database. Vector embeddings transform unstructured data into vectors. So vectors are points in multidimensional space that capture semantic meanings. This allows you to compare information based on similarity of meaning and not just exact matches. When someone asks a question, the system turns that question into numerical representation, then looks for the closest match in the vector database. Relevant chunks are returned and a response is constructed. Now, this is an extremely successful model. However, general AI using vector search has fundamental limitations. Every chunk is treated independently. There are no understanding or relationships between the chunks. It can be context blind. It cannot understand your domain. And as the knowledge base grows from thousands to millions of documents, the system starts struggling to find right answers quickly and precisely. So now let's look at GraphRAG. To understand GraphRAG, let's talk about three main components in play. Firstly, it's the ontology. An ontology is an official blueprint or rules of the universe for your data. It defines the exact concepts, categories, and relationships that exist within a specific industry. For BSI, proof of concept, we use the NALT ontology. So NALT stands for National Agricultural Library Thesaurus, and it's produced by the USDA. We had extended it with New Zealand-specific terminologies to help Caitlyn have a localized understanding of common agricultural concepts. Depending on your industry and your subject matter, we'll have to choose the best ontology for you or work with you to build on top of one. Next is Caitlyn's ingestion pipeline. This is Caitlyn's own IP. We have built a truly impressive 14-step ingestion method. The pipeline reads your unstructured data, extracts the important concepts and entities, and uses the ontology to structure that data perfectly. The last piece is Neo4j's graph database. This is where those connections actually live. Here we store data as nodes and edges. And that's just a very fancy way of saying things and how things are related. GraphRAG doesn't replace standard vector search. It builds right on top of it. It adds a new layer of structure and a way to search by how things are related. So you get the best of both worlds and the agent can decide which to use. For example, if you ask Caitlyn, how many days do I need to wait before harvesting? This is a direct and factual question, and the agent could use just the vector method to provide an answer for you. But if you ask, give me all the reports published by this author, when the question involves coverage, relationships, or completeness, the agent will opt to use graph to provide an answer. The graph follows explicit logical links rather than just word similarities, and the answers are entirely traceable and repeatable. And you can see exactly why something was returned to you. So what does that mean for us? So Caitlyn's primary focus over the last few years was to build trust with its users. How many of us have asked AI the same questions multiple times only to get different answers each time? Each answer looks convincing, but different. In vector-only RAG, when you ask a question, the chunk fetched each time could be different. All will be relevant, but not be the same each time. This is why you find each response might be different to the previous one. The responses are varied and probability-based, and because of this, we describe this as non-deterministic retrieval. In GraphRAG solutions, the graph follows explicit logical links. So each time you receive the same chunks back. While the response might be, slightly constructed differently, it's still constructed using the same information. Therefore, it's consistent, formula-driven, and GraphRAG gives you deterministic retrieval. When you ask Caitlyn a question, you'll normally witness the agent's thinking. You can see the question being broken down into search topics. But in GraphRAG implementation, you will be able to expand on these steps and see the path the agent takes on the graph to produce your response. GraphRAG also has a deep understanding of your domain language. Weed killer, Roundup, herbicides, these are all mapped onto the same concept. So nothing slips through the crack just because someone used a different word in their questions. So BSI had the opportunity to experience a vector-only Caitlyn in parallel with a GraphRAG version to see how they compare. And the proof of concept in a nutshell was Caitlyn deployed securely inside BSI's own environment. Sensitive content was gated, not hidden. Citations that were built for researchers, and the real differentiator being GraphRAG, giving them not just the answers, but a map of what they actually know.